Are we good to go? Okay, cool. So hey guys, I'm Steve from Dora Hacks and Dora Factory team. Happy to really happy to host this workshop together with our um, team members and also our community partners. So today we're going to talk about MACI. We just launched a MACI use case hackathon on the Dora platform to actually, I think, call upon all of the community to think about what are some of the use cases for MACI. Um, and we're definitely explaining what is MACI and why this matters to you shortly after in this workshop. But before that, let me briefly introduce all of our guests. So today I'm actually joined by Claire, operational captain from our ops team. Um, yeah, and
Hello.
we also have guests joining us from all over the world, including East Bucharest, Comments of Web3, um, University of Calgary Blockchain Society. We have Amir joining us, and also Non-Geek team. I want to thank you all for taking your precious time to join us in this discussion on the use case of MACI in this workshop. Um, so the workshop will probably start with us briefly explaining what is MACI at all, and how are we using them in some of the scenarios. And we'll also, I think, save a lot of time for discussions, which like everyone is actually encouraged to participate about what are some of the use cases, or if there's any question, happy to answer them. So yeah, let me move on. So um, I think let me really get into MACI first. So what is MACI? MACI in general is privacy voting. Um, so why we're talking about privacy voting at all? So it's like two words, privacy and voting. Um, we want to start with voting itself. So voting is not as common as, some of the other actions that we have day to day, like eating or running. So voting doesn't really happen every day, but voting is still very, very important to us. Um, as as people, we vote for certain stuffs. We vote for who is our next president. We vote for who is our next president of the student union, universities. We vote for leaders in a corporate. We vote for like certain proposals in a decentralized community, like a DAO. The DAO can be as big as um, deciding $1 billion treasury or deciding how a blockchain is going to evolve. Are we increasing our inflation rate? Are we decreasing our inflation rate as a blockchain? That can really change this ecosystem. So voting really happens every day. Um, and why blockchain can really improve voting in general is that there are certain problems in those votings traditionally with the traditional methods. So in traditional voting, there's um, you know, there's problems with transparency. So when you actually don't vote on chain, you can't really make sure that all of the votes are genuine or like real votes. For instance, some of them fabricate the votes, duplicate the votes, change the votes. You can't really know. So also like there's problems like collusion. Um, for instance, like the votees can bribe the voters, especially like if there's a huge financial incentive after that, or the votee is like a really good friend of the voter. Um, so this kind of collusion happens all the time. So a really important narrative is that blockchain can improve voting in general. So this is actually one of the real use cases of blockchain and crypto in general. Because like blockchain, when people talk about how blockchain can really change people's lives as a frontier technology, a lot of people think about the financial side of things. So blockchain is on-chain transaction. So we're actually creating a decentralized finance ecosystem. infrastructure to actually change what's going on with the traditional financial world. But also blockchain have this um, really, really cool features that can actually build trust and solidify um, like really, really important results as an application as well. So we're actually using a really important feature of blockchain to solve a very specific problem here. So MACI is actually a more advanced version of on-chain voting proposed by Vitalik Buterin in 2019 as one of the core use cases for blockchain in general. MACI was proposed as minimum anti-collusion infrastructure to actually solve some of the collusion problem that's already seen in on-chain voting. For instance, a project raising public goods funding from the community can promise airdrops to bribe the voters. A lot of projects actually did that in the past. So how can we create a system to prevent that from happening? How can I vote for a project on chain without revealing my identity and prevent the votees to actually bribe the voters with airdrops and all the other perks and opportunities? So this is what we're going to discuss today. We're going to talk about MACI, how it's like we're actually less talking about how we're realizing MACI with Z technology. That's like a more technical topic that could take like a totally like another 2 to 3 hours to go in depth. Today we're more focusing about if MACI is happening, we have this amazing technology. How can we use it? First, how can we actually use it? And second, what are some of the real life use cases? So I'm going to give like a really quick rundown of MACI in general. And Claire is going to share a little bit about a real use cases happen in the Dora community that we leveraged MACI to improve community decision making. And um, and then we can discuss basically how can we use MACI in some of the real life use cases. Like I mentioned, why MACI is important. Um, there's all kinds of reasons to actually alter the results, like with bribery and collusion. So a lot of the time, really want to prevent that from happening. A voting system with bribery, voting system with collusion is tremendously different from one without. So right now, what we have on all of the blockchain is that all of the voting is on-chain, all of the voting is public. There's absolutely no way to protect privacy of the voters at all. So this is why I always say like we're actually so early in blockchain technology that there's actually so much to build. And this is actually why MACI matters. Like if you really understand MACI, you actually be shocked to know that how nascent we are in blockchain application development. So like I mentioned, when all of the on-chain voting is transparent, there's certainly definitely a lot of benefits. So there's actually no one that can actually hide on a lot of those voting decision making. So I'm putting an example here on Cosmos Hub. How the community make decision collectively is by delegating their Atom token, Cosmos Hub native token, to a specific validator of the network. And then the validator is going to vote on behalf of all of the delegators on specific governance proposals. So it's very transparent right now that you can see each validator voted yes, no, no with veto or abstain on a certain topic. So everything is transparent, which is good. And validators actually not just incentivized, but also encouraged um, to actually like express their opinions on a governance proposal. But some of the bribery already happened. For instance, there's some of the whales in the Cosmos community that want certain proposals to pass. And how they're bribing the community is if the community validator voted in favor of his proposal, he will actually add delegation to the validators. So this is definitely kind of bribery and collusion that happened. Um, Yeah, so just like making example here of how is it right now and what are some of the problems out there. So MACI is going to voting on-chain private. So this is actually a great technology that first provides privacy for the voters, and second, can still make sure that all of the voting results are correct because we're actually using MACI, using ZK to tally the votes afterwards. Um, so I'm not saying that MACI can prevent collusion, but with this technology, a lot of the previously easy collusion methods can be mitigated. Um, like I mentioned, we're not going to dive into the technical details in this workshop, but there's actually, if you're interested in this technology or even interested in further developing this technology, our team is always there to chat with you probably after this workshop. So privacy voting can be used for a lot of the scenarios. Our team has like came up with some ideas ourselves. The largest or the most influential ones from my perspective is that we could really use MACI in government elections. It can be as small as a very small jurisdiction to as large as United States election. From my point of view, if we're using blockchain technology in government elections in the future, we have to use MACI. Imagine you voted for a president elect, a president candidate without like you have to reveal your identity. Like that doesn't really work. But it's also like very useful for some of the day-to-day DAO operations. So for instance, you started a DAO with a really good friend and he made a very stupid proposal. You have to vote no, but you don't want to hurt his feelings. So you definitely want some privacy, you know? So you want to vote no because you think it's the right thing. You want privacy because you don't want to hurt his feelings. Um, like community funding management, protocol upgrades. So a lot of the times when I actually participate in those kind of voting, um, when some of the subordinates are voting for their leaders in a corporate, they definitely want privacy. So MACI could be really, really useful in a lot of the use cases. But happy to like pick your brain on like what are some of the use cases that you can think of in your day-to-day scenarios as well. And also like I'd love to share a little bit of like MACI experiments on the Dora side. So we actually have been developing and implementing MACI in a lot of the use cases. So we actually have been implementing it in some of the hackathons that we co-hosted with OpenSea, with ZeroX, with East Denver. So you might be interested in how we're actually using MACI there. So basically, we're engaging the judges to vote for all of the hackathon participants with MACI. So the judges will vote for the projects privately using MACI, and all of the projects will actually be ranked based on the voting results without having to see which judge voted how many votes for which project. Um, so it is like a very small experiment compared with, national elections, like millions of people participating. But it's actually a really interesting experiment as a lot of those, I would say, um, really, really like good like unicorns or like community organizers that's actually very open-minded and they tried MACI, they loved it. Compare with some of the other more traditional judging process and on-chain governance like community management process. And we're really trying to push adoption for MACI since then. But we have been starting to doing this since I would say 2021, 2022. So like I mentioned, Southern Plus developers used MACI in those hackathons, and more than 20,000 community members participated in MACI on-chain voting. And more than $1 million of funding has been distributed to those public goods in multi-chain using MACI. So we're actually pretty proud of this, as we're actually one of the first team that achieved this. So like I mentioned, we have used MACI in Dora Grandel. voting rounds, which is on-chain community funding initiative to fund early stage public goods and startups. And we used MACI there. So we engaged the community to cast votes for candidates in our own community funding rounds. We have used it in 0x Hackathon. So not only is a quadratic voting round for the 0x Hackathon, it's also MACI. So like 0x and OpenSea are a few really, really cool teams that tried this cutting edge technology. And we're most proud with East Denver 2022, where Dora team was the co-host, and we engaged the whole East Denver community to try MACI. We actually built this on Polygon back in 2022, and the whole East Denver community participated in their winner selection from 30 eligible finalists to 5 teams. They eventually won East Denver 22 that year. They were selected with MACI. Yeah, so I guess I'll stop here and I'll let Claire take over to share a little bit more about some of the experiments that we had recently on actually leveraging MACI product that we built and to launch a round, a privacy voting round.
Yes, yes. Can everybody see my screen?
Yeah.
Awesome. So yeah, I'll start. So following Steve's speech, I'll start with how to design a MACI voting mechanism for your own ecosystem. You may want to ask that, okay, MACI is good. MACI is like, I don't really understand, but it sounds cool. But how can I what can I do with it? So next, I'm going to introduce some mechanisms and some use cases to you to understand more details about MACI. So first of all, how to design a MACI voting mechanism. We use MACI mechanism because we don't want bribery, we don't want nepotism or anyone voting just for friendship. We don't want maybe just I don't want to show my votes to others. That can be the only reason we want to use MACI. So how does a MACI voting mechanism usually work? First of all, in a lot of cases, especially in Web3, in like blockchain governance proposals, we have to vote for approve or disapprove. So case one is we give one voter one vote to approve to vote for approve or disapprove a certain proposal. A very commonly seen example is governance proposals in different blockchains. And here's a screenshot with ongoing governance proposals on the Aptos blockchain. Actually, you can find numerous of similar use cases on any other blockchain. And if you want to, like, if you have a lot of proposals for everyone to vote yes or no, you just start multiple rounds of proposal voting. And here, like, if you don't want others to know what you are voting for, like, if I want to vote for no for this proposal. And as Steve mentioned, but this topic was proposed by my friend. I don't want to hurt his feelings. So I don't want him to know that I vetoed his proposal. Actually, MACI is working perfectly for this kind of case. And secondly, we have actually in 2024, we have a lot of presidential election sessions all over the world in different countries. So in such cases, a voter who has one vote should vote for one option from multiple options. This is quite commonly seen in traditional industries like or in traditional organizations like the presidential election, of course, And sometimes you need to select your group leader. Sometimes you need to select your community admin. So in such cases, we can also implement MACI voting to choose the best option for us. And the third one is quadratic voting with MACI. So this case is one of like Dora expertise because we have run a lot of MACI-based quadratic voting for different partners in the Web3 field, like OpenSea, like Eastanver, like ZeroX, and a lot more. So in such a voting mechanism, you need to show your preference toward different options. Here you will be introduced to something called voice credits. You can understand voice credits like limited voting tickets. So like let's say you have 10 voting tickets or 10 voice credits to be distributed to 3 your favorite projects among 100 hackathon project submissions. This is what the judges usually do during in judging in a judging session during a hackathon. So but here we have two cases for such situation. One is for judges, they only give votes, and according to the votes the projects receive from the judges, there we can see first prize, second prize, third prize. And here you can see in my screenshot, there's something called matching pool. This is a different situation like we implemented in Eastanver, is that community voting also decides how the funds should be distributed. Like the matching pool, the distribution of the matching pool is determined by the distribution of voice credits. So actually, quadratic voting is can not only be used for selecting winners or others it can also be used for managing the funds in an organization. So like as you can see in Eastanver, hackathon prize pool distribution is a very typical case for us. And then let's dive into a more specific example here. So let me introduce Dora Dojo to you. Dora Dojo is a knowledge sharing community, which means the community members, they propose the topics they want to study from time to time. Like there are some topics on cryptography, on AI, on Web3 security, so on and so forth. And for the chosen topics or for the approved proposals, the proposer, they should learn about this topic. They should give a session to introduce his learnings and his insights about this topic, and then he can get a bounty from Dora Dojo. So actually the members are quite actively proposing topics in the community every day. But the thing is, initially the proposals were approved by the Dora Dojo admins, but admins, they have very limited knowledge. So when it comes to some topics they don't know about, it's very difficult for them to decide whether to approve this proposal or not. So here we need the power from the community, like the community altogether, they are wiser than us, than the Dora Dojo admins, and like their choice, like their collective choice is more convincing to let us know which topic is more necessary for the community to learn next. So here for Dora Dojo, they introduced MACI community voting to their community. They invited 21 representatives from their community to join the voting panel. And altogether, they were voting for 7 proposed topics from submitted during December and this January. So as you can see, here's one of the proposal topic here. It's called Theoretical Cryptography Series. And if you're curious about this specific case, here's the link to the proposal. And we will share the link to this platform later. So yeah, the MACI voting session was successfully wrapped up. And how did people like it? We did a little survey among the voters. 10 voters answered, gave us their replies. So, but it's not a very like scientific, well-designed survey, but it still shows some facts. The question one is, do you prefer privacy voting or non-privacy voting? 9 out of 10 voters chose privacy voting because the answers are quite similar. I can vote without any physiological burden. I can vote just for the sake of the options. I don't have to think about some other things. I just need to show my preference to this topic itself. The second question is, if it was not massive voting, would you change your choice? 4 out of 10 said they would, because if I voted disapprove for a proposal and I personally know the proposer, it may hurt his feeling or ruin our friendship or something. And 6 out of 10 said they would not because they don't know the proposers personally, so they don't care. This also like shows some facts that if the voters are like, especially in some small communities, everyone knows everyone. So if the voter knows the proposers personally, it will strongly like greatly impact their choice to give votes. And how did Dora Voda implemented their like MACI voting mechanism on the blockchain? Actually, the Dora Dojo team, they were not technical. They're just ordinary people like us, and they don't know how to code. They don't know the technical fundamentals of MACI. They know the mechanism of MACI, but that's it. So they use a one-stop no-code platform called Dora Voda. On Dora Voda, you can very easily implement your own MACI voting session and use various types of voting mechanisms as I introduced earlier. And this platform is developed by Dora Factory. And if you want to experience this platform yourself, just go to vota.dorafactory.org. Yeah, and last but not the least, if you have any questions on MACI and on this workshop, just feel free to contact us via Telegram at DoraHacksOfficial. And we have a hackathon to reward good MACI use cases. Like if you can implement MACI in your community for some very meaningful purpose, just let us know, submit your use case to the hackathon, and the judges they will vote for your use case also in a MACI voting session, and you will get some rewards from this hackathon. Yeah, I think that's all for my part. So give the mic back to Steve.
Yeah. So we're going to Q&A, right?
Yes. Oh, sorry. I think we left something like unexplained in the workshop. So maybe I can start asking some personal questions from my end
Oh,
to
sure.
Steve. Yeah, to Steve and maybe to Eric. Eric just joined us. Eric is also Eric is the founder of Dora Hacks and Dora Factory, and he's also the architect of the Dora Voda infrastructure.
Yeah.
Mhm. So first of all, we just introduced the Dora Voda to everyone, but actually it's a governance infrastructure based on Cosmos. So why did the team choose Cosmos rather than Ethereum or other ecosystems to build Dora Voda, this governance infrastructure?
Yeah, I think I can talk about that. Yeah, so actually, the very first version of Dora Hex Mason was built on Solidity, um and in order to build that, uh is uh we have to use some more fundamental infrastructures, and I think about two or 2.5 years ago, uh, the Ethereum Foundation PSC group posted something called MACI 1.0. So the very first version of Dora Hex QF MACI, which was used in the Stanford round as well as a few other rounds mentioned by Steve, uh, that contract uh, was developed based on MACI 1.0. Um, so that is a great open source repo. Um, so and later, obviously, we can still deploy a lot of runs with Solidity. You can deploy on Polygon. You can deploy on other EVM chains. So it's not very difficult. But for non-EVM chains, it's pretty hard. So so in 2023, uh, because a lot of hackathons organized on Dora Hacks. So we do have a lot of EVM chain hackathons and grants, but we also have many other communities from the crypto world. Therefore, like whether we can let all of these people access MACI as their governance mechanism became pretty important. Um, and and one of the most important SDK was the Cosmos SDK. Right? A lot of the app chains, a lot of the blockchains emerging from 2022 and 2023 were built from Cosmos SDK. And then we thought about that. There were like infrastructures uh, built on top of Cosmos Blossom, etc. So that you can build like original zero knowledge applications, um, but uh, but very few infrastructure, like very few repositories were really proven. So we were thinking about whether we can rapidly uh, develop MACI as an application, because the application is what we care about. Um, so the approach we used was to to reuse as much as possible what we had, and build up the application on uh, on different chains. And obviously, the first um, ecosystem in large is the Cosmos ecosystem. So the way we structured uh, the the MACI project, uh, was that because in a MACI round you have different steps, right? You have a round, and then the voters will be casting their votes. So these votes have to be casted to the target chain. So if the chain is a non-EVM chain, you have to have a non-EVM contract. However, uh, most of the other tasks will be completed off-chain, meaning that the operator can votes and generate zero knowledge proof without uh, being blockchain specific. So that means most of the tools we can reuse, and mostly we will just migrate the MACI smart contract to the multi-chain ecosystem. So what we did was we did a few hacks. We posted a few repos, and those repos allow us uh, to create MACI rounds uh, on any Cosmos SDK based chains. So that's what we were doing in the I would say it's the first half of 2023. And obviously, what you're seeing is Dora is deployed on a specific chain. It's a application specific chain, and with Dora we can continue developing and improving MACI as a tool as well as an infrastructure. So it gives us much more flexibility to develop and evolve this infrastructure in the future. Yeah, so just to give some background here.
Okay, thanks so much. And sorry, guys, I'm gonna use my privilege to ask questions again. So this question is to Steve. You just mentioned a lot of like miraculous cases for MACI. Like we can use MACI to do this and do that, but we know that MACI is not omnipotent. So what does MACI not able to be not able to do, and what are the best cases do you think we should use MACI and do not use MACI?
Yeah, very good question. So we definitely hope that more like organizations can adopt MACI in their voting. But definitely we don't need privacy for all of the voting, if that makes sense. So like some of the examples that I can think of are, for instance, for some of the voting, we actually need the voters to publicly express their opinions in those votings. So like public votes. So sometimes in corporates, there's some board meetings, board decisions. You actually need each board member to express their votes to say I'm voting yes or no on this specific topic. And also like in some of the pollings, like you want the voters to reveal their identity as well. So I'm publicly expressing my opinion, and just like voting is just like a process there. And also like in some of the government decision making, I do think that a lot of the votes are public as well. So in certain scenarios, voting is public. That includes government's decision making, like a government is setting up a new law. Sometimes the process is private, meaning that you don't really know that which governor voted yes or no on specific proposal. Sometimes they do. And in corporate governance, sometimes it's public. Like you actually need this person to express their opinion on specific topics sometimes. And also in some of the less formal voting scenarios, like a group of friends that's deciding what to eat, you know, if you're using like a small blockchain gadget to vote for, hey, we're gonna eat tonight, you actually don't have to like do everything privately. So I do think privacy is very important in a lot of the scenarios. Also, we don't have to use that sometimes.
Yeah, so I think that makes sense. And also, I would have to point out that MACI is not a very complicated process. It's rather simple. If you can just see like the whole process of MACI can be pretty much encapsulated uh, within a very simple user experience. And I think that's the beauty of MACI. However, there are uh, um, limits of MACI. So it's not almighty. It's it can solve something, but it cannot solve everything in voting. But I think the importance of such mechanism or technology is that uh, before we have infrastructures to develop zero knowledge proof applications, uh, this kind of privacy voting is not uh, that private and it's not very easy to implement. But with blockchain, together with zero knowledge proof technology, you can make very simple user experience out of this technology. But specifically for MACI, I think uh, like the original version of MACI was uh, was a pretty simple process, and obviously the operator knows everything, right? So whoever tallies votes, that person has to decrypt all of the user's votes. So obviously that person has access to every piece of information. So if the operator is corrupted, then there's no point. Um, but I think this problem can be mitigated up to a certain uh, stake. So if you are a community or if you are a hackathon organizer and you are distributing, let's say, a few $1,000s, uh, even up to a few $100,000, the operator will probably not cheat. However, if you have a more um, high stake or critical uh, voting, like a state election or important corporate governance decision making that involves hundreds of millions of dollars, then you cannot trust the operator too much. Unfortunately, there are some research articles out there talking about different approaches to make operator not be able to know who voted for what. Um, Currently, this uh, research involve, this like additional mechanism involves more complicated process. In fact, we did uh, do some experiments. I think last year uh, in April or May we did a Ethereum research grant, and that was the first time we tested a more complicated version of MACI, which is the anonymous with MACI using a more complicated mechanism. So basically, what that was doing was like you uh, you have uh, you enable the users to to deactivate their private keys for for the voting run and then register uh, a new key, but the operator cannot know which user registered what key. So that is the basic idea of anonymous MACI. Um, so we actually built that uh, on Solidity. Uh, we tested it it's pretty complicated, but I think it's meaningful. So if you have a more critical run, if you have more funding to distribute, then eventually we have to solve this operators problem. But I think the current platform we are developing on Dora Volta is only enabling the most basic version of MACI. It can already solve other problems in voting. So if you have a community and you like all the voters want some privacy, this is going to be a very good platform to use. If you have a hackathon or you have a quite a big funding round, um, and you can deploy your own MACI round very easily.
Thanks so much, Steve and Eric. And then I think it's time for our guests to raise our hand here and give questions. The first one to raise hand is Mishka. So yeah, Mishka, please.
Yeah. Thanks a lot, Claire. I was just thinking about the security aspect of the MACI rounds that we're talking about. I know when it's at, a nascent level, at a more regulated level, it's easier to sort of look at it. But, when it's like a more widely adopted technology, what are like the, different attacks that can happen on, let's say, creating MACI rounds, for example, maybe like Sybil attacks, some sort of fake grants creation. Like, how do we look at it when it's a more widely adopted technology? And how do we regulate all these kinds of different attacks that might happen?
Yeah, I think for MACI, it's quite easy to mitigate a civil attack because the first stage of MACI is to sign up. So it's pretty much whitelisted. Obviously, we can whitelist a lot of people, but it's like a gateway. You can have so if like if you have a community, for example, like in an election, you must have your ID card, and you have to register that ID card before voting. So let's imagine that you are using MACI in a general election or something. You can register these voters, and so these voters can register their keys by giving a signature to prove their ownership of the keys. So I think this happens before the sign up session. So what is the second part of the question? The security issue.
Yeah, it was also about, let's say, a fake grant that has been created. And, I get all my friends to sort of apply to via different bills or projects to it.
The fee grant?
A fake grant, let's say, a malicious
Oh,
operation.
yeah. Yeah, so Steve, do you want to take on this?
I think if it's a grant program, is there a way to like, prove that the grant is there? Like, so I think if it's launched by a reputable organization, it should be less a problem. But it's a newer organization that is less familiar, never launched a MACI round or like a QF or like a community funding round before. It will be more tricky. So some of the ways to mitigate this is to have somehow like a community, or like a custodian, like a decentralized or centralized custodian service providers custody some a part of the fund or all of the fund, which actually has been one of the topics that we discussed before. But I don't think MACI, can solve this problem. But more as in, it's actually very common that someone hosted a hackathon in Dora, and sometimes they cannot pay out the prize pool, even though they intend to when they launch the hackathon. So it's more like a reputation system around the one that's launching those rounds. But I don't think it's directly related to MACI. if I understood this correctly.
There's some other scenarios. For example, you have a okay, let's say you're hosting a hackathon together with a quadratic funding round. That's something that happens pretty often on Dora Hacks platform. So from the hackathon, you probably have like 100 builders, and then you're selecting 5 builders or 10 builders from that hackathon. So whenever you have that MACI round, so I say it's a QF MACI round, and when you have that round, you have pre-selected uh, builders for users to vote for. Um, versus there are other cases like if it's free admission, uh, so in the early days of quadratic voting and quadratic funding rounds, uh, we actually had several like free admission quadratic funding rounds. Any builder can register that round freely. There were some problems indeed, because some of the projects could be um, not fitting that round. Sometimes it's not actively developing. Yeah, so I think the like in this kind of scenario, you have pre-selected projects admitted into the round, so that the users are sure that they're voting for something real.
Got it. Thanks a lot.
Yeah, Mishka just gave us a case like mentioned by Steve and Eric earlier. If there is a corrupted operator of the run, MACI cannot help us solve the problem. Yeah, so next question go to Emil. I saw Emil raising your hand. Emil, please unmute yourself.
Hi everyone. Thanks a lot for taking my question. So I'm like also I appreciate sharing all the capabilities on MACI. So my question is regarding scaling MACI. How can communities simplify and communicate MACI to engage and onboard communities and users that are either completely new or at a beginner level in blockchain? And will there be strategies and educational tools that will be employed to ensure that Web3 beginner communities can also effectively understand and utilize MACI for their governance needs?
Yeah, this is a very good question. I can just drop a few examples. As I believe we're like really, really early till that day, but there's something that we can try. I think Eric can amplify later. So a few things. Right now, we are building the minimum version of MACI to actually encourage all of the community organizers to build use cases around this technology. So as open source or like as a small or big community organizer, you could potentially use it in the election of like the blockchain community in University of Calgary, for example, in your student union election. Um, so basically, I think we are a little bit far away from having a tremendously good UI for this kind of like voting apps, but I don't think it's impossible. Um, so I think 2024 exciting, especially exciting about this. So UI UX is very important for not just MACI, a lot of the blockchain applications. So basically, we want a user experience that they're not really realizing they're using blockchain as a backend, or like they have to know about MACI at all. They can be using it with the experience of like participating on a polling on Twitter, I think. Or they can just go on this specific website designed for this election, and they don't even have to, maybe in the future they don't even have to have their own wallet. in their own way. But I think it's just like very, very far away from today. Um, but like in this process, we can break it down. Do they need to register? Like do they need to sign signatures with the blockchain like a browser extension wallet? And how are they paying gas there? Because like for them to sign a transaction to participate in the voting, they need to have some kind of gas. So a little bit more down to earth in what's going to happen this year. I think what are some of the interesting ways to encourage adoption is that we can reimburse or like to cover for all of the gas. For instance, like we have been developing this feature called gas station where a sponsor can actually sponsor all of the gas for the transactions that's happening in this MACI voting round. That when voters actually vote in those MACI rounds on the Dora voter blockchain that we develop for them, they don't actually need to have Dora token to vote. It's actually sponsored by someone else. That's just one of the ways that we are trying to improve the experience. But I think we're still like very, very far away from the Twitter experience, participating in on-chain polling in a really smooth, with a really smooth UI UX. But I'm not saying it's impossible. We actually want to see more amazing front-end UI UX designers, developers to actually build this. Let's see if Eric have more to share here.
Yeah, that's actually true. We are definitely the user experience problem is one of the biggest problems in the early stage of using and adopting MACI. And like back to 2021, there was literally no UI. So if you want to use MACI, yeah, I think I have to give credit to ClearFund. They had a very early UI. Um, um, it's it's functioning, but definitely back to 2021, you had very few UIs that you can use. So I think the most like the first UI that is user friendly to the quadratic voting and hackathon community was the Dora Hacks UI developed for Istanbul 2022. By that time, we had a much nicer UI that supported a lot more people in a single event to vote for their favorite project. However, that UI was not a UI for every kind of voting round because the Dora Hacks UI was only for voting for hackathons and grants. But outside of that, you have many other kind of use cases. You have elections, you have DAO governance, you have many other kind of use cases to think about. So one goal of the Dora Volta UI is to provide a very minimum interface for people who want to create a MACI round. So if you want to create a MACI round, you can create a MACI round very fast. And if you want to manage a MACI round, you can do that as well. So the way it was designed is that it's almost like a blockchain explorer, but it's a explorer for MACI, right? So you can see your own round and other people's round because every round is a smart contract on the Dora Volta app chain. And if you enter that page, you can see all kinds of different information about that round. However, we're not providing a lot more than that because an election voting round, I mean, the UI for that is going to be very, very different from a hackathon voting. Yeah, so that will also require people to build their own UI. So I think the idea is that if we can make MACI itself easier to use, I mean to create and manage, then the only thing left is you have to build the UI. And for that, we have a minimalistic UI that you can access from all the voting rounds on Dora Vota right now. That is the super clean and minimum UI that you can use. We have been developing that. We will be opening source that repo pretty soon. And hopefully, so if people want to build their own UI, I think they can refer to our minimalistic UI. But definitely, I think right now, if you have a use case and you think it's necessary to build a UI, you can do it. It's not going to be very hard. If it's just voting and you feel you don't have to build a UI, you can use our existing UI, the minimum version. That will still work.
Okay, thanks for introducing Dora Vota. Right. So next question is from Diana. Diana is from Commonwealth Web3. Hi, Diana.
Hey, how are you?
Great. Please raise your question here.
Yeah, thank you so much. And thank you so much, Eric, Steve, and Claire for the presentation. Very interesting project, like great job. Yeah, we need more privacy, right, in blockchain. Well, we need as well like transparency, but yeah, indeed there are like a lot of use cases that need privacy, as you were speaking. I have tons of questions, to be honest. Like, but yeah, I will just say just a few. So one of the question is, how is the MACI or like in the platform? How are you able to allow only the vetted users to vote on a proposal, right? So you guys were talking about, I don't know, voting like a DAO would use the MACI to vote on a proposal. How like your platform knows which are the DAO members, right? Like how would that be, or like how you would give the rights of voting on the proposals?
All right, yeah. So Dora Vota is for communities to run their own MACI. So the way users will use Dora Vota is like you, for example, you are a community manager, and then you go to Dora Vota and then you create a MACI round. By the time you create a MACI round, you're actually deploying a smart contract on your own behalf. So you will become the operator of that MACI round. And from the script side, you will be generating the Z key and you will register your operator's key, but the private key of that operator public key will be only owned by yourself. So here we're just providing the tool. So if someone deploys a MACI round, we won't be able to know what their private key is. So that operator will be in charge of his or her MACI round. So if the private key of that operator is lost, then that round is dead. Yeah. So so the Dora Volta enables like people to manage their own round. But whether that operator is honest, is tallying the votes in the right way. I think so there is only so much a operator can do evil, right? The operator cannot create fake votes. So if you are running this MACI round, you cannot modify the results and give the correct zero knowledge proof because you won't be able to. And the only thing you can do is you never publish the results. So let's say you get the result that doesn't favor yourself, and let's say an evil operator, what that operator could do is that that evil operator can just delay the tallying or just not publishing anything. So
yeah, my question was more thinking about like existing communities, and especially in Cosmos, there are already communities like, and see like every blockchain has its own community. There are like DAOs as well. So how, like, I was thinking, if like basically having MACI, like the communities needs to transition on Dora Vota, or they can stay on the platforms where they are right now already, and just use, I don't know, the voting capability there. And if yes, how would that be? How would that work? So
yeah,
that's why.
so
Yeah.
right. So using Dora Volta so the purpose of building Dora Volta is that we can make it simpler by developing the necessary UIs and tools, scripts, etc. But if you're running a MACI, I say you want to run it on Polygon, you can for example, you can use MACI 1.0, or you can fork DoraHack's MACI QF repo, and you can just deploy that contract. That will work. Yeah, so I think either way will work. But maybe over time, using Dora Volta will make it easier.
Yeah.
Yeah, but I think for Cosmos community, it's definitely easier and more efficient to use Volta. Because the Volta MACI rounds are Cosmos Awesome smart contracts, but for a Ethereum community, probably it's easier to deploy a Solidity contract on some low cost chains. So we posted an article on Dora Research blog a few months ago. We actually discussed different possibilities of building MACI infrastructure. One way is that you just use smart contracts, right? So whenever you want it, you just deploy some smart contract. You can deploy it on Polygon or some L2s or L3s to lower the cost. But you know, smart contracts are just smart contracts. There's only so much you can improve. Those are just individual rounds. There is the possibility of building a specific layer 2 or layer X to lower the cost and also improve the infrastructure itself. Currently, I haven't been seeing that. Maybe the newly formed Ethereum PSC ZK MACI, so they have a project called ZK MACI. I think that's something they could do. Also on the Dora Volta side, Dora Volta is I think it's very friendly to Cosmos Wasm users. So any I mean the interchain ecosystems, whatever. So if you have a Cosmos SDK chain, it's really easy to transfer some credits or tokens using IBC from some chain to Dora Volta, and then Dora Volta can be used. Yeah, so there are definitely different possibilities. We actually had a discussion in the article.
Yeah, thank you, and thank you so much for also like talking about Cosmos, right? Because another question was around how the vote or like the voting results it's casted back or to the, I don't know, to the community or like to the other chains, or how, because see, like you were talking about validators that are polluting or bribery and so on and so forth. But in the same time, you were talking about small small organizations, right? Where people know each other, right? So maybe that's so probably for like in my mind, what comes right now is that probably small organizations, it's fairly easy to come to Dora Vota, but for more larger communities that are already formed on other platforms, like yeah, it's interesting to understand like how easy is to come on Dora Vota, and if they would be coming only for the voting part, right? Or there are like a fully fledged governance platform.
Yeah, that's actually a very interesting question. So I think for the easiest part, the for Cosmos chains, right? It's fairly easy because there is IBC and you can use IBC transfer tokens and with minimum cost. But if it's okay, let's say a DAO on Ethereum wants to vote in MACI, I think there is so there is a trade-off between the cost and the trustworthiness, right? If you vote on Ethereum, basically the infrastructure is more decentralized. But if you vote on an L2, it might not be that reliable, but the cost will be lower. So there is a trade-off, and I think this trade-off is definitely there. For AppChain, I think the trade-off will be okay. So I say let's consider the market cap of Dora Volta, right? So like let's say what is the market cap of this chain, and what like how much value has been staked into the validators of Dora Volta, and I think that will be the question of Dora Volta. So one thing an AppChain has to do is to gradually decentralize itself. So I say if I have a smaller validator set, you cannot support a high stake voting round worth like billions of dollars. If you want to support that, you have to increase the security of the infrastructure. So the trade-off will be real. But yeah, thanks for the question. It's a great question.
Thank you so much.
Yeah, thanks for the question, Diana. And I think your first question was about like the qualification for voters. Like how can we identify which voters are qualified to get involved in this voting session? So actually we have a example from East Denver. So East Denver, they requested to only allow like verified voters to join the voting session, of course, on MACI. So how do we solve that issue? First of all, before East Denver Hackathon, we communicated with East Denver and decided to use they have a token called Spock. So we decided to invite all the Spock holders to join the voting session. So in a MACI voting session, you can upload a whitelisted a list of whitelisted voters. So actually all of the Spock DAO holders, because we have their addresses on the blockchain. So we just put the addresses of the Spock token holders in a whitelist, and we just allow the whitelisters to get involved in the voting session. And it's quite similar for Dora Voter actually, because you can upload a whitelist before voting on the Dora Voter platform. Maybe they can be some token holder, even can be some NFT holder, or some pre-registered addresses you have before some qualification process. So that's usually the way how we identify who are the qualified voters to join the voting session.
Yeah, makes sense. Thank you so much, Claire.
Thank you so much for the question. And for other guests, if you have any other questions, please raise your hand or just leave a comment in the chat section. So we're waiting for the next one. Okay, so maybe before the next ones, I can use my privilege again to ask some questions. I'm sorry, I'm from this team, but I have a lot of questions about our team and product itself. So for we just introduced the example from Dora Dojo, which is a organization we're very familiar, but how do you think like is MACI voting mechanism can be a voting mechanism for Dora Dojo to use for a long term? Like will there be a better voting mechanism than MACI voting mechanism for organizations like Dora Dojo?
Yeah. So I think MACI has two things. So first, MACI is providing privacy for voters, which is important for not just Dora Dojo, but for any organization that's launching this kind of on-chain voting and appreciate this kind of privacy preserving features. So that's one thing. Second thing, I think MACI is trying to prevent collusion. So why collusion is a very, very big problem is specifically for some of the very important decision-making process for, I think, the benefit for a certain group of community. For instance, when we're electing leaders for as big as a nation, as small as a corporate, to the decision of public goods funding, which is more applying for Dora Dojo. So basically, Dora Dojo is applying public goods funding for research topics to be covered by a certain researcher to a group of community that's interested in all kinds of frontier tech topics. So like we have discussed, MACI cannot solve everything. There's more advanced voting, like I think mechanisms that can actually be invented. So there's quadratic funding. There could be like more advanced, interesting, also privacy preserving voting mechanism to be developed in the future, because like there's so many smart people out there. Eventually we'll come up with something that's more robust or like better products in general. But I think MACI could be one of the really, really interesting and important options out there for a very long time. And we're just like discussing MACI so much in depth today, as I think it's definitely worthy of more attention in general. Because like right now what we're having for all of the on-chain voting itself is that there's different like use cases out there, but not a lot of them is focused on privacy. This is why MACI is important. It deserves more discussion in general. it deserves more adoption should we actually want blockchain to be adopted in those real life voting use cases. Yeah, so it will always be an option there, and it might be a stepping stone for more advanced voting mechanisms. But I do think that it could be used not just by Dojo, but for a lot of organizations, whether it's managing an on-chain community or um, a, a not so decentralized community in general, for a really long time, is what I think.
Yeah, thanks, Steve, for the answer. And yeah, is there anyone want to ask a question? Here's Chris. Yes.
Yeah, so I think I just want to ask very specific niche questions on Bribel. So pretty much like MACI can prevent at the very last step by voting that basically the grant initiator cannot see who vote for them. So that this can prevent the Bribel. But like, what if the grant initiator or the people who applied for the grant has started to communicate with the voters beforehand about the Bribel, so that actually the last step of the voting will not be matter because the voter have already be bribed. And also like if like do you think this is part of the potential this is part of the piece that MACI can put potential to help and solve with, or this is something that MACI might not be able to solve at this stage?
It sounds like the social engineering side of attack. I think okay, let's say if two people trying to collude and they just stay together and one person is watching another person to vote and make sure that person doesn't vote again until the end of the round. You cannot prevent this kind of collusion. However, so actually, the current implementations of MACI, they all have some simplifications. So you can add some designs into the mechanism so that it's more robust. Let's say you are going to have a deposit. This was actually described in the very early post of MACI from Vitalik. Like the very original version of MACI has a deposit mechanism. So you have to make a deposit. So if you're caught to sell keys, so essentially you're selling your keys, right? So it's just in different ways. If you're selling your keys, then you probably will lose your deposit because you can put the deposit, let's say 50 ETH or some Dora tokens into that address. And if you sell your key to another person, and that person can just take your deposit. So to some extent, this is going to be preventing collusion a little bit or bribery. But to a larger extent, I think so. I see. Imagine a scenario where okay, let's say quadratic funding, right? One of the common ways for bribery in quadratic funding is that some project that hopes to receive fund promises some airdrop or some reward if you vote for them, if you donate to their project. And this is a very common kind of collusion that is very difficult to prevent in pure quadratic funding scenario, because that project can just post on Twitter, and there's very little things you can do, or they can just post in the Discord channel. You might not even know about that. But in MACI, it's really difficult for the voters to prove they voted for the project, because all the votes will be encrypted, and there is no way they can prove that. And the votes can be recasted, right? If you cast your vote in MACI, you can revote. Yeah, so unless you just stick to that person and make sure that person doesn't revote, I think that mechanism will work. Especially in like in the community. So I would say the privacy side, like the feature, will be more about like if people know each other, and then they probably want privacy. But if when in a round where people do not know each other, they so the anti-collusion feature will emerge, because then you have people who cannot prove they voted for what, then they cannot be bribed.
Yeah, got it. Makes sense. Thanks, Eric.
You're welcome, Chris.
Oh, I'm here. Okay, so maybe one last question. Let's see, is there anyone raising a hand? There's Yan raising his hand. Yan, please.
I would like to touch on this question from Chris. So like in case there's any like civil attacks detected, is there like any framework to like mitigate these risks? Or is there like also an implementation of some sort of like resolution for disputes?
Yeah, I think for MACI, the civil attack problem is not a very severe one, unless you have so I think the MACI mechanism abstracted away the sign up process. So because the sign up process is the very first one, right? So you pretty much leave it out, and the operator or the community can design any way for their users to sign up. The actual MACI process is just for voting and tallying and proving this tallied result is correct. But the sign up process happens beforehand. So the only interface of MACI for the sign up is that you can register, and probably you can give a whitelist. But how did you get the whitelist? The communities can, or the operators can design different ways. They can just use the whitelist because they know everyone. They can use some reputation, on-chain or off-chain reputation kind of thing, or they can use some kind of proof of stake, or they can have certain criteria. That depends on the nature of the voting round. So I think civil attacks happens mostly when you have you have to admit other people, especially you have to admit a lot of addresses, but you cannot identify these addresses. And I think that's where a Sybil attack will often happen. And in that case, I think it's not MACI's job, but if you can have a legitimate whitelist, I think MACI's job is to provide privacy together with anti-collusion features.
Thank you.
Yeah, but I think the Sybil prevention problem is actually a much more open-ended and much more difficult problem. There was a I think once Vitalik was talking about the thing called encapsulated complexity versus systematic complexity. I think MACI is something that you can so the whole mechanism is encapsulated. So the actual interface is pretty simple, but Sybil attack is a pretty open problem. So if you have an open community, if you have a closed community, you can just whitelist everyone. But if you have an open community, especially like on-chain community where everyone is just represented by an address, then whatever mechanism you invent to prevent Sybil, there will be some countermeasure. So it's like an endless war for Sybil attack.
Understood. And in case like a Sybil attack is detected, would there be like a second vote with like different parameters, different measurements, or like what could be a solution?
Yeah, like in quadratic, so in MACI there won't be any solution. The only thing you can do is to restart a new round. But in the context of quadratic voting and especially quadratic funding, I think there is a whole bunch of mechanism that you can borrow if you want to deal with Sybil. One way of doing that is post-round analysis, right? So you analyze the data and then you use some pattern recognition or some empirical experience to exclude some of the votes, some of the users. However, that's going to be more centralized because you don't know how these people are excluded. But if you post like how you do it, then the Sybil attackers can do better. If you close source it, then you can do evil. So that's a post round analysis. A lot of drawbacks. I think you also want to implement some reputation or credit scores, probably, and just let people join with different reputation or credit scores, and then they have when they vote they have different weights. That's another way of dealing with that. And you can also add some cost to the participation, just to filter out the the very basic version of Sybil attack is like dust attack. You can just create like 100 addresses and you can vote for one project or one option, and you can add some initial cost so that you can filter out these addresses. Yeah, but I think civil attack is the much more complex problem there.
Thanks a lot for the great response.
Yeah, thanks a lot for the questions and answers. Actually, I didn't realize that we already had this workshop for 100 minutes. Thanks everyone. We talked about security, we talked about good and evil, we talked about corrupted operators, every aspect and details of MACI. And also shout out to the Dora team, Steve and Eric, and our honorable community grantees, East Bucharest, Commerce of Web3, and University of Calgary DeFi Lab. Thanks so much, guys, for joining us today. And of course, last but not the least, we are running a hackathon called MACI Use Case Hackathon. So if you have a good use case of MACI, please join with your use case details to submit it to dorahacks.io. Just type MACI in the search bar. You will see the MACI use case hackathon. Just submit it as a project, and your use case will be reviewed also by the invited voters, and also be like judged by MACI, the mechanism itself. Yeah, thanks so much everyone for joining us out this live stream noise, because we will upload the recorded video to YouTube and Twitter. So see you guys next time. Bye-bye.
Thank you. Have a great
Thank you,
day.
guys.
Bye.
Have a good
Thank
night.
you.
Thank you, everyone.
Bye-bye.